Okay, so today is going to be our last day on word problems. So we're going to do a little review of the types of problems that we've done. And then on Thursday, we're going to move on to talk about functions. Our objective today, students will be able to solve different types of word problems. All right, you guys are going to go ahead and do a little activity, match the vocabulary terms with their definitions.
How do we do that?
You move the tiles around on your Pear Deck. You should be able to move things to match them up.
Just have to click it. Click both.
All right, so constant would have been a number by itself. Term is a piece of an expression or an equation. Keywords are words that commonly stand for specific operations in math. Variable is a letter in an expression or equation. Coefficient is a number right next to a letter. Integer is a number that is not a decimal or a fraction. Equation has to have an equal sign. And consecutive means in a row. All right, so we're going to go over 3 different word problems today. So here's number 1. For a field trip, 4 students rode in cars and the rest filled 9 buses. How many students were in each bus if 472 students were on the trip? All right. So, what is this situation about? So I like this answer because it's pretty thorough. It is about a field trip and how many students are in each bus. Most of you answered something along those lines. So great. This was a pretty good, succinct answer, got to the point. So I like that. All right. Next part. For a field trip, 4 students rode in cars and the rest filled 9 buses. How many students were in each bus if 472 students were on the trip? What is the important information in this question? Okay, so this student we have a lot of people found some of the information. But this was pretty good, this one. I like this one. Where they really kind of figured out the exact things here.
Yeah.
All right, so in this one, for a field trip, 4 students rode in cars and the rest filled 9 buses. How many students were in each bus if 472 students were on the trip? Define your variable, set up your equation, and solve for your variable. So let's take a look. I don't know that anybody had this exactly. There's some people on the right path. Let's see what this person put. All right, so good, they broke all that down. I'm gonna actually go ahead and show you guys what I was looking for on this. So you need to define your variable. So you're gonna use the word let, and you can use whatever letter you want. I'm gonna use X. So whatever your variable is, it stands for something. It's standing in for something. In this case, it was number of students on a bus. Would have been faster to type. I can't do cursive because kids can't read cursive. I used to when I taught geometry teaching cursive, and those kids could read it. My cursive handwriting is actually pretty good. All right, number of students on a bus. So now we have to figure out how to set up our equation. So we know if 4 of these students rode in a car, they're just off by themselves. Okay, there's no multiplication. You're just adding these 4 students on, right? And we know that there were 472 students on the trip total. That's going to be on the other side of the equal sign. And when I add these up, I have 9 buses. All right, and the number of students on a bus. You notice bus and bus, usually they'll have some sort of word in common. The variable and the thing you multiply times that variable. And you get that. All right, so now we can solve. We get 9x equals 468. Then we divide by 9. And you get 52. All right, moving on. All right, you are going to you know that x equals 52. So how can you write a sentence that answers the question?
Okay.
Okay, so let's see. This one's perfect. I like this one a lot. All right, there were 52 students on each of the 9 buses. Perfect. That is a perfect answer. I could not have asked for a better answer. So excellent job on that. All right, example number 2. The sum of 3 consecutive even numbers is 48. What are the smallest of these numbers? All right, all you're doing to start is I want you to write 3 different algebraic expressions you could use to represent the 3 numbers. What should that look like before you write an equation? So it looks like we got a little off on this one. I'm looking at the answers, and I'm not seeing anybody that got it quite right, although this one's really close. So I'll share this one. Although, yeah, there's something. Still gonna share this one. I'd like to talk about this one because it's on the right track. The thinking is there. All right, so they had consecutive even integers. That part's great. That's where you're going, but those were not the integers we were looking for. And I could see they were kind of getting there. X, X2, X4. You need a plus sign in between. So those would be the 3 things right there. X, X plus 2, X plus 4. Because remember when you have all those numbers, right, you want to go to even integers. You're going from here and you're jumping here, here. You're adding 2 to get up to the next one. And then to get to the next one, you need to add another 2. So to get from our X to get all the way up to 6, you'd go 1, 2, 3, 4. And that's why you'd add 4 on. Okay, so keep it moving here. The sum of 3 consecutive even in numbers is 48. What are the smallest of these numbers? Let x equal first number, x plus 2 equals second number, x plus 4 equals third number. All right, set up your equation. So this one looks pretty good. You have your x plus 2 plus x plus 4 equals, not sure why there's a negative sign at the end, but otherwise that's absolutely perfect. Very nice work. All right, so you have your equation. Now I want you to find x. Looks like we got some pretty good things here going on. Yeah, let's go with this one. So yeah, they took the terms, they combined them on the left. You don't see that, but this is what you'd get when you add up x plus 2 plus x plus 4. You get 3x plus 6, and it's just a two-step equation. Subtract 6 from both sides, divide, so you get 14, and then to figure out the other numbers, you would get 16 and 18. That's pretty good. All right, and now you're going to write a sentence that answers the question. Now remember, the question is, what are the smallest of these numbers?